Hi, and welcome back to 5-Minute Chemistry with Always Eclectic Stacy. This is our covalent bonding series, and today we're talking about the VSEPR and Lewis structure, example number 12, and this is with molecular geometry. Let's go. Welcome back to Always Eclectic Stacy. This is our 5-minute series, and we're still doing VSEPR and Lewis structures today. This is example 12, and today we're going to be looking at NH₃. This is nitrogen trihydride, because we always want to make sure we're naming them properly and using both the chemical formula or the molecular formula and the proper names. Now, the first thing we're going to do is check the polarity. Now, nitrogen is more in the center, and we know hydrogen has one of the lowest polarities or electronegativities on the periodic table. So I always put that one with a higher polarity or electronegativity first. So nitrogen is 3.0, and hydrogen is 2.1. And I'm getting these off the periodic table of electronegativity. So you can go ahead and reference that. When you subtract them, the difference is 0.9. So we know that this is going to be very polar. Now, the next thing we're going to go ahead and do is draw our Lewis dots just as a reference point. So remember, nitrogen is in the 15th column, so it has 5 valence electrons. So you can go left, right, up, down, right 5 times, and you can see that it has 1, 2, 3 places for it to potentially bond, and there's 3 hydrogens. So now we're beginning to make sense that the 3 hydrogens are going to bond to nitrogen. The hydrogen is in column 1. It only has 1 valence electron, and it's always terminal, meaning it's always on an end. It can never be a central atom. It always has to be on the end. Remember, that's the same with column 17. So we're going to go ahead and put nitrogen in the middle. Don't forget to do that. And we know the electronegativity or the polarity is going to go towards nitrogen because it's got the higher electronegativity. So we're going to kind of bend these down a little bit to show that dipole moment. So you're going to kind of bend them down like this. So you're kind of not going straight across. We're kind of bending them down to show that dipole moment. This is going to be more positive on this side and negative on this side. So we need to make sure that we're properly showing things kind of the positives going towards the positives and the negatives, because it does make a dipole moment, meaning 2 poles, 1 positive pole, 1 negative pole. Now what we have to do is, now that we have a central atom, one very clearly things are attached to it, it's just not 2 things, you count the number of bonding pairs. And there are 3 bonding pairs, and I will show you that this is a bonding pair, this is a bonding pair, this is a bonding pair. So 1, 2, 3 bonding pairs. And then you look at the number of lone pairs only on the central atom. And there's 1 lone pair right on top of the central atom. And we look at those because the lone pairs take up a little more space, and that's kind of also what you're showing here, that space that lone pair takes up. So it kind of takes more space and bends things down. So we know it's very polar or polar with 3 bonding pairs and 1 lone pair. So, excuse me, we're going to look up our VSEPR shapes or our molecular geometry. And this is a trigonal planar shape. Don't forget that you have to show your poles, and you determine that by your electronegativity. It's always going to be more positive towards the lower electronegativity and more negative towards the higher electronegativity. Thank you so much for joining us. This was Always Eclectic Stacy with 5-Minute Chemistry with VSEPR and Lewis structures for nitrogen trihydride. Don't forget to like and subscribe if you like our content.